All right. Today we're going to talk about lesson 9-3, graphing y equals ax squared plus bx plus c. Okay? These are also quadratic functions, okay? Quadratic equations. The graphs of a quadratic function with an equation in this form is a parabola whose vertex can be found from the values of a, b, and c. So we're going to show you how you can find the vertex and other important things, as well as if it goes up or down, depending on its graph. So let's get into this. How far does a car travel after brakes are applied? When a driver decides to stop a car, it takes time to react and press the brake. Then it takes time for the car to slow down. The total distance traveled in this time is called the stopping distance of the car. The faster the car is traveling, the greater the distance it takes to stop the car. So it takes longer to stop a car if you're going 70 miles per hour as opposed to 55 miles per hour. A formula that relates the speed x in miles per hour of a car and its stopping distance d in feet is d equals 0.05 x squared plus x. So this is the equation we're going to use in order to show a car's stopping distance in feet. This is an important piece of information. You need to know that for quizzes and tests. That equation right there, distance equals 0.05 x squared plus x. What does that look like? Well, when you graph it, obviously we don't need negative numbers because you can't go negative speed. Okay? So what they did for us was put this in a table for us. So at 10 miles per hour, it takes 15 feet to stop. At 20 miles per hour, it takes 40 feet to stop. 30, 75 feet, all the way to 70 miles per hour, which it takes 315 feet to stop. Okay? Now, over here they graph that. Speed in miles per hour is our x. Stopping distance is our y. So, say for instance 50 miles per hour, it takes 175 miles per hour, or 175 feet in order to stop. Notice this graph resembles a graph of a parabola that we've been looking at. Properties of the graph of y equals ax squared plus bx plus c. The equation d equals 0.05 x squared plus x is in the form y equals ax squared plus bx plus c, with d taking the place for y. Okay? A is 0.05, b is 1, and since there is no c value in this case, c is 0. The graph of the equation of this form, provided that a does not equal 0, is a parabola. So whenever you get an equation in this form, it is a parabola. Moreover, every parabola has a vertical line of symmetry and has an equation of this form. The values of a, b, and c determine where the parabola is positioned in the plane and whether it opens up or down. Same as before, a tells you if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens downward. Okay, much like before. So in this case, 0.05 is our a. 0.05 is positive, so we knew that that was going up. Let's look at example 1. It says graph f of x equals a negative 2x squared minus 3x plus 8. Use a window big enough to show the vertex of the parabola, the two x-intercepts, and the y-intercept. Remember, you have to change your window. It's not up to your calculator's job. So here they have the x max at 5. They have the x minimum at a negative 5. Y max at 10, the Y minimum at a negative 10. You can do this, type this into your Y1 onto your calculator, put this window in for on your computer, on your calculator, and you're going to get the same picture. Okay, I went ahead and did it for you. Okay, now it says estimate the vertex, the x-intercepts, and the y-intercepts. Well, my vertex is my highest point, or where the axis of symmetry and the parabola intersect at. And it looks like our axis of symmetry runs right through here. Okay, about right in the middle. So my vertex is a coordinate point. And my coordinate point for this is going to be, it's close to a -1, but not really. So I'm going to say negative 0.85, comma, and the height is about 9. Okay? Now, if you said a -1, I'm probably not going to hesitate to give you that as a correct answer. Okay, but there's my vertex. My x-intercepts. My x-intercept is where it crosses the x-axis. Here's my x-axis. We have 2 points where it crosses the x-axis. Okay, here it crossed at a -3. And it crossed here at 1.3, positive. Now, don't get this confused with a couple days ago. This parabola is moved. It's not in the same place anymore. Okay? Remember we talked about parabolas where the vertex was always the origin. That's not this way in this case. Our vertex is a different number. So when my parabola moves, it's not going to be a -3 and a +3. You have to check these. And these are my x-intercepts. My y-intercepts is where it crosses the y-axis. My y-axis is right here. Well, this crossed in one spot, and that spot is at 8. So my y-intercept is 8. Moving along, example 2. It says, find the exact location of the vertex of the parabola that is the graph of f of x is equal to a -2x squared minus 3x plus 8 from example 1. Here's a good way to show how to find a vertex when looking at a table. Okay? I like using the graph because I can then, when I look at the graph, I know where the maximum point is or where the minimum point is. I know where the vertex is at. It's at the furthest top of the hill or the bottom part of the hill. If you're looking at a table, how do you know if you have a vertex? Well, if you look here, they start repeating themselves. Because remember, as it goes up, it's got to come back down, or as it comes down, it has to come back up. So if you look here is, the 9s are the same. The 9.08s are the same. And the 9.12s are the same. So what it looks like is we probably had a vertex at approximately a -0.75. Notice the difference from us just guesstimating where it was at, as opposed to looking at the table and getting a more precise answer. Okay? Let's look at activity 1. It says graph these two coordinates, or these two functions, y equals 2x squared and y equals 2x squared minus 10 on the same axis. So let's go ahead and do that. Y equals 2x squared and 2x squared minus 10. And I hit graph. Okay, here is the first one, my 2x squared. Here's my second one, the 2x squared minus 10. Okay? Both of these look similar together. Same width, looks like. If I were to move this up, it looks like they would lie on the same thing, right? A says, what is the y-intercept of y equals 2x squared? Well, my y-intercept is where it crosses the y-axis. It crossed the y-axis at 0. So 0 is my y-intercept. B says, what is the y-intercept of y equals 2x squared minus 10? Well, if I scroll down here, it is at a negative 10. Okay? Notice the difference. Okay? This one doesn't have anything added on to it. Has a y-intercept of 0. This one has on to it a c value. We know it's a c value because it's just a number. Okay? Of a negative 10, and its y-intercept is at a negative 10. Describe how the two graphs are related. They are the same with different y-intercepts. Okay? They are the same with two different y-intercepts. Let's look at step 2. The two functions they want us to put in is a negative 0.75x squared and a negative 0.75x squared plus 1. Okay? Now, you guys can probably assume what this is going to look like. I'm going to make my window a little bit bigger. Make my y min a negative 20. Hit graph. Okay, so it goes down a little bit further. But as you can see, there's the first one that went through 0, 0. The second one actually goes through 0, 1. Okay, it's actually one step higher. So my y-intercept for this, because there is nothing, is 0. My y-intercept for this is 1. Describe how they are the same. They are the same with different y-intercepts. Same thing. This has a y-intercept of 1. This has a y-intercept of 0. Okay? It says graph y equals 2x squared plus c for 3 different values of c, with at least one of these values negative. Give the equations that you graphed and what is the effect of c on the graphs. Well, we should know just by looking at these two things. This one, it moved this graph 10 units down. This one, it moved the graph 1 unit up. So what is the effect of c on the graphs? It moves the graphs vertically up or down. Okay? Vertical means up or down. So that's what C does. It moves our graph up or down. Let's look at activity 2. Determine the effect of B on the graph of a quadratic function. Consider the function y equals x squared plus bx minus 4. Graph this function of 3 different values of b given in the table below. Fill in the table, okay? So, let's type these into our calculator, and I'm going to do these just one at a time, okay? So, the first one is x squared plus 2x minus 4. So, x squared plus 2x minus 4. We hit graph. Okay. What's our vertex? Well, a vertex looks like it's going to be roughly a -1, and I want to say it's a -4. Okay? Because this is kind of rounding it for us, our C should tell us that it's at 4. Okay? So, my vertex is a -1 and a -4.75. A -1 and a -4.75. Okay? My y-intercept, where it crosses the y-intercept. My y-intercept is going to be right about at 4 is where it's crossing at, or at a -4. Okay? And this tells me what my C is, this right here. So all these are going to be a -4. Okay? My B in this case is 2. That's that number right there. So this one's 2, this one's 4, and this one is a -3. Okay? What's my x-intercepts? My x-intercepts for this one is a -3.4, -3.4, and say 1.27. Okay? Let's type in the next one. And all that changes is this number right here, my B, which is, in this case, a +4. I'm going to hit graph. Okay, looks like the same. We got the y-intercept is 4. I'm going to scroll over. I'm going to find my x and y intercepts. For my x-intercept. My x-intercept, -4.8. And so it looks like it moved a little bit. This is now at 1.06, so I'm just going to put and 1.06. My vertex now is at -1.9, comma, -7.6. Okay. Let's do the last one. We put in a -3, I believe. Yep. Hit graph. Find a vertex. This definitely changed. Notice that our y-intercept is still at 4, just like it was on the last one. My vertex is roughly at 1.48 and a -6.2. Negative. My x-intercepts. This one looks to be almost a -1. Very close. -1.06. And -4.2, -1.06, and 4.2. It says, what features of the graph of y equals x squared plus bx minus 4 does the value of b affect? Well, it affects two things, it looks like. It affects the vertex and the x-intercepts. Those are the only two things that changed. My y-intercept stayed the same, as this question asks. Okay? And we're not going to do step 2, but those are things that you're going to want to do is you're going to want to make your graph big enough so you can see all these things here. You can see your x-intercepts, you can see your y-intercept, and you can see your vertex. So some of you guys need to get really familiar with this calculator and using the window and making it bigger. That's all I have for you today. We'll see you tomorrow.